Alright, this is day 44 of AP Calculus with Sparks. It says more on particle motion. We're going to be finding net and total distance. So we're given here a graph representing the velocity of a particle moving along the x-axis. So it helps me to write what graph I have so that I can remember that that is the velocity function and recall that acceleration is equal to the derivative of velocity, which is equal to the second derivative of the position function, like that. So what values of t does the particle have no acceleration? So again, this is the velocity graph, and they want to know about the acceleration on the interval, the open interval, 0 to 10. So the acceleration is equal to the derivative of the function that we're given. So where does the acceleration or the derivative not exist? It's going to happen on all of these cusps. We're not counting endpoints because we're dealing with an open interval. So a of t is undefined at t equals 1, 3, 6, and 8. And we know this because graph of v of t has cusps. So now we're going to write a function for the acceleration piecewise on the same interval. Take some time to figure out what that is and hit pause, and I will give you the answer. Alright, notice that we don't have any equals signs because the acceleration, as we discussed up here, is undefined at each one of those cusps. So now let's talk about when is the particle moving to the right and when it's moving to the left. So it's going to be moving to the right. I'm going to justify this too. Since v of t is greater than 0, the particle is moving right, and that happens between 0 and 2, and then again from 7 to 10, and then moving left when v of t is less than 0, and that occurs between 2 and 7. Alright, so you try finding the average acceleration on the interval 1 to 8 and check your answer. You might want to pause this. And voila, I get 0 for the average acceleration from 1 to 8. This is 0, and we were in meters per second squared. And we turn the page. So we write down a couple of definitions. The definition of net distance and the definition of total distance. So the net distance is the distance between the beginning point and the final point. So the total displacements, wherever it started, subtract wherever it ended, and there you go. So if it started here, and went here, and then back to here, and then here, and then here, this right here would be your net distance. Total distance is going to be the sum of all distances. Traveled. We're going to add up all those pieces, so that'll be the difference. Alright, if a particle is moving in the same direction the entire amount of time, what can be said about the net distance and the total distance? Well, if the particle only moves in this direction, regardless how fast or slow, oops, I have a little hiccup in there, then the net distance would be equal to the total distance. Because it never once turned and went the other direction and got closer to the beginning. Alright, let's write down how we would find the net distance. So on AB, the net distance is going to be the absolute value of P of A minus P of B. That is my stomach growling. If we want to find the total distance, well, let's say it went this way, and then turned around and came here, and then this way, and then back this way. We're going to need to add up all those parts. So if this is a point C, and this is a point D, and this is a point E, and this being B where it ends up, and this being A right there, we'd have to add up all those pieces. So each of the net distances there, we're going to add up. So we're going to have, let's see, if the particle never changes direction, then total distance is the absolute value of P of A minus P of B, but if the particle changes the direction at C, which is inside of AB, then total distance is the absolute value of P of A minus P of C, the place where it turned around, and we add to it the absolute value of P of C plus P of B. And we could add on if we had more points like that. So let's go ahead and try an example. So we want to know the net and total distance of this particle. Here's our interval, 1.5 to 4, and here is our position function. So net is going to be the absolute value of P of 1.5 minus P of 4. We need to plug 1.5 and 4 into the function, and you should get out, if you want to pause it and do it right now, I'm going to give you the answer. 58.75, and we're in centimeters because we're talking about the distance traveled. So for total distance, we're going to have to do a little bit more work. We're going to have to figure out if this thing changes direction on the interval 1.5 to 4. So we know that when the velocity is positive, it's moving right. When it's negative, it's going left. So if we could find the zeros of the velocity function, then we would know where this would turn around. So P prime of t, which is equal to velocity, equal to 6t squared minus 12t plus 8. So pause it right here and find the zeros of that velocity function. Alright, this turns out it was not factorable, and it turns out there are no real zeros because 36 is less than 48 underneath that square root. So, sorry, that wasn't a very nice problem. But what that does tell us then is that the net distance equals the total distance because B of t is greater than 0 for all domain, or especially this interval. Alright, turn the page and we'll try another one. Alright, so it doesn't say calc like it does a lot of times in this book. This is definitely a calculator problem because they're asking us to do manipulations with E and evaluate stuff. So the function P of t is equal to e to the 2t minus 8t. We're dealing with feet. So we want to find the net and total distance. Why don't you give it a whirl and see what you come up with. So I thought I'd check in right here before I actually found the total distance, just by finding the 0. And I checked to see if this really was a change of direction rather than just maybe a point of inflection or something like that. What happens if you didn't check that? Nothing. You would just probably do a little extra work and come out with the net distance is equal to the total distance, so that's not a big deal. And then now I'm going to go ahead and do the total distance on the other side of that line. There you go. And actually, it was almost the same, but not quite the same. A little longer, the total distance. Alright, go ahead and try the next example, and pause it and check out the answer in just a sec. Alright, there you go. There's my work, there's my answers, that's how I did it, and I got 3.617 feet. Alright, catch you next time.